Hello everyone, my name's Yahir Hernandez, and I am from Chicago, Illinois, at the amazing, awesome, epic NCP High School, the astronomically amazing high school. So today we're going to be talking about integrating vectored valued functions. This is topic 9.5 from the AP Calculus BC curriculum, and let's dive straight into it. So let's ask ourselves the question, what is a vectored valued function? Well, I like to define it in terms of derivatives. This is easy for us to see in integration, which is what we're focusing on. So r prime of t is equal to this f prime of t g prime of t. That's kind of confusing, but let's see what it would really mean. A set of parametric equation. That kind of helps. Let's see an example. R prime of t is equal to e to the 3t, 1 divided by square root of t squared minus 1. So, in essence, that kind of looks like just a pair of functions. Integration of vectored valued functions. So the integration of this is actually really simple. It's just integrating two functions and putting it together. That's the best way I like to put it, is to simplify it to its best terms. So don't be scared when you're looking at these types of problems. We're going to take it one step at a time and it'll all work out. So let's see how integration will work. So we have our derivative function from earlier, and let's integrate. So we add, the integral of r prime of t dt, okay, and it would just become r of t is equal to f of t plus c, g of t plus c. Okay, cool. It's just a normal integration. So this is the AP Calculus BC, the College Board, their like way of defining indefinite integration. If you like to prefer to do it this way, that's of course up to you. Sorry for blocking the screen, but that's of course up to you if you would like to do it this way. They have this I and J method. It's really cool. I've never seen it before, but that's pretty cool. So we have definite integration. So now we have bounds. So that means it has to be more difficult, right? No, not necessarily. It's just the same thing as integration, just with like definite integrals. So we have like the fundamental theorem thing where it's consistent f of b or big F of b minus big F of a. Um, it's consistent with that. If that's how you'd like to see it. So remember, the two functions must be continuous on the closed interval a to b. Remember that. So what are some common misconceptions about this? Well, forgetting the plus c, of course. Remember, we're integrating here, right? Never forget the plus c. It's integral when you're integrating. Do you get it? Anyways, remember, when in doubt, plus c. Remember your integration rules. We're gonna integrate, so to effectively integrate, make sure you know the different types of integration techniques, like U substitution, integration by parts, integration with like partial fractions, etc. Different plus c values. The c value for the first function, f of t, is going to have a different c value for the second function, g of t. We use c subscript 1 and c subscript 2 to distinguish the two. You'll see this in the later examples right now, that we're going to do actually right now. And remember, plus c. So example 1, integrate the following function. Okay, v of t is equal, okay, so we have the two functions. Let's pull the first one, let's integrate that one. So then scroll 3e to the t dt. Okay, I'm gonna pull out the constant. Always gotta do that. Okay, this is a decent integral. This is pretty simple. It's just e to the t plus c, of course. Subscript 1 is the first function. And you can always check this by taking the derivative. Make sure it's the function that you get. It would be the same thing. Integrating the second function. Okay, this is kind of a weird integral. Do I want to do integration by parts, or do I want to do integration, U substitution? Well, actually, this is an integral that you should kind of be familiar with. The derivative of what function gives you this? Well, the derivative of the arc cosine of t gives you this function of negative 1 over square root of 1 minus t squared. So, our answer is arc cosine of t plus c subscript 2. Now remember, we're not done yet. We need to put it together. Bring the functions together. We get this. This is our answer. Voila, beautiful. The integral v of t is equal to 3 e to the t plus c subscript 1, r cosine of t plus c subscript 2. Example 2. What is v of t? Oh, sorry, I'm blocking the screen. What is v of t if, oh, what is v of t if v of 1 is equal to pi e squared? Now we have values. This is kind of weird, and there's an integral, so I think we need to integrate the functions. Let's start with the first one. Finding the first integral and first c value. Okay, so let's integrate the first function. So we could pull out the constant, of course. This is a nice integral as well. It's just the natural absolute value of t. Remember, absolute value. And you have the 3, multiply it, plus c subscript 1. Remember, different c value. So we can now substitute our values because we do have that the input is 1, the output is pi. So we can do pi is equal to 3 times natural log of 1, the absolute value of 1, plus c subscript 1 to get our c value. And we get that it's actually just pi. So cool. So we can then just find our first function. I'm just going to substitute it. This is how it would kind of look like. Let's move on to the second integral. So the integral of 2e to the 2t dt. Okay, well, kind of want to like think about like reversing it. Like if I were to have taken a derivative of 2e to the 2t, what would I get? Well, I would get 4e to the 2t. So if I would go backwards, that means I would just have no no coefficient, or I would have a coefficient. It would just be 1. So it's kind of like dividing by 2. In a way, kind of like reversing it. So it would just be e to the 2t plus c subscript 2, and that is correct. If you just take the derivative to check, substitute the values, it's just 0, no c value, unfortunately. And our answer is v of t is equal to 3 natural log of t plus pi e to the 2t. Thank you so much for watching, and I hope I have helped you learn some calculus. Goodbye.